So for our last day, we're covering 10.9 and 10.10, working with the circumference of and the area of a circle. So work with each of these respectively. So we'll start with 10.9 with the circumference of a circle. And our definition of the circumference is the distance around the outside edge of a circle. So previously, up to this point in time, we had worked with the idea of the perimeter of a shape, the perimeter of a rectangle, the perimeter of a square, of a pentagon, things like that. And the perimeter is the general term that also equates to the distance around the outside of a shape. Well, the circumference is the exact same thing, but it is specific to the area, I shouldn't say the area, the distance around the outside edge of a circle. So it means the exact same thing, but the circumference is specific to determining that length for a circle. Perimeter is for all shapes. Circumference is specifically for circles. So a subtle distinguishing piece there, but it's a part of the vocabulary that I think is worth noting all the same. So when we're working with circles, we have two very, very, very important qualities and properties that go along with them. We have the radius, and that's the straight line distance from the center of the circle all the way out to its edge. And in contrast to that, we have the diameter. The diameter goes across the center of the circle, goes from one side to the other. The diameter is twice as long as the radius of the circle. So I'm jumping us over to our geometry info PDF. Nice visual over there. We'll zoom us in here a little bit. So we have a circle. And we have, it's in the center here. It's not exactly drawn to scale, but we're going to assume it's there. We have the center of this thing. So the radius, again, is that from the center to an edge. Doesn't matter if it's right here, doesn't matter if it's right here, doesn't matter if it's right here. It's always from the center of the circle out to the edge of that thing. The diameter is from one edge of the circle to the other edge, going through that center part. So it could be completely horizontal, it could be completely vertical, it could be kind of diagonal with these, doesn't matter. It is always from one edge of the circle to the other, going through the middle. As we're seeing with this as well, okay, so if the radius is from the center all the way out, the diameter is from one end to the other, the diameter could also be written as the diameter is equal to 2 times the radius, because it's double the length of the radius. You could also think of it as the radius is half as long as the diameter. So we can go back and forth between having both of these things calculated if we know at least one of them. So we'll jump back to our notes here. And our last piece of information that we have is pi, the symbol that we see right here. And it's the ratio of the circumference divided by the diameter of a circle that we are working with. And it is always going to have the value of 3.14, I think it's 159, it's got a bunch of numbers that comes after it. Now, the book in a lot of places define pi to just be 3.14. Again, it turns out that pi is actually a number that goes on forever, which means we are going to get very big, very long, very gross decimals showing up with this. So when you are using your calculator in pi, there's actually a symbol in there that we can use to type in pi. And this also does mean that it's going to have that big, long decimal version of it, which means our answers are going to have lots and lots of decimal places in them. For the homework, and more specifically for the test when it comes around for that, I will be doing my best to specify to you guys round your final answer to the nearest tenth, hundredth, thousandth, anything like that. So when you do plug pi times a bunch of other stuff into your calculator, you'll get a big, long, gross decimal answer, but you will know where to round it to. Again, I don't want you guys having to guess at what I'm looking for a final answer, so I will do my best to specify that to you guys where to round accordingly. It will be on you to plug the necessary numbers and plugging in pi into your calculator correctly, though. And we'll go through an example or two of doing that with the calculator here in a little bit. So first thing we're going to work with, we're working with the circumference. So let's get our actual equation out here. So our general equation for the circumference of a circle is C is equal to pi times d. So our circumference is equal to pi times the diameter. So d is the diameter of the circle. Now remember, just because it's written this way, we do know that we can kind of interchange the diameter and the radius based on what we have been given. Remember that the diameter is twice as long as the radius, or vice versa. The radius is half the length of the diameter, which means just because it's written this way doesn't necessarily mean we are always going to be given the diameter explicitly of that circle. We might have to work with rewriting our radius and diameter based on the information that we have been given. And we're going to see that this is going to show up in 10.10 as well when we're working with the radius of a circle too. So my recommendation, as I've said a few times, I think, up to this point in time now, when you're working with these, draw a picture for yourself. And it's very, very helpful with all of these types of problems. So we're going to reference several of these, or these 4 examples. I'm going to jump us over to our Blackboard, and we'll go through a couple of these over there. And I will also show you guys how you would plug this thing into your calculator as well. Whoops. There we go. Sorry about that. Okay, so we're working with finding the circumference or finding the diameter or radius of some of these things. So our first example that we had, we were told find the circumference of a circle with a diameter of 12 feet. So my recommendation again to everyone, draw a picture for yourself. It doesn't need to be perfect. We've got something, we've got a circle that's shown up there. Find circumference with a diameter of 12 feet. So let's draw that in. So we've got our center that we have here. And again, you don't need to actually draw anything to be completely perfect. You guys have seen me draw throughout this entire quarter, and I'm no artist. We have our diameter there. We've been told that the diameter is 12 feet long. So we have 12 feet. Now we are asked to find the circumference of this thing. And again, my recommendation to you guys whenever you're doing this, what shape am I working with? What equation am I working with? And once you figure that out, write that general equation somewhere on your paper. Because we're going to be referencing it, we're going to be using it. So we're finding the circumference. We have been given the diameter. Fantastic. I'm just plugging in C. Not C. I'm plugging in 12 in for the diameter. So that's the information that I have been given. So we're getting C is equal to 12 times pi. Now, entering this thing, I'm going to go through solving several of these before we get into plugging 12 pi into the calculator. So for now, we're going to leave our answer like this. We are going to come back to it and calculate more of these things out, but I want to go through at least the process of getting to this point with a few examples first. We will come back to the calculator here shortly. But for now, we would plug in, again, just that 12 in for the diameter, and our circumference is going to be 12 times pi. And we'll get a big, long, gross decimal showing up out of that, and we'll deal with that here in a little bit. Looking at number 2. We're told find the circumference of the circle with a radius of 7.8 inches. So again, draw a picture for yourself. Find the circumference of the circle with a radius of 7.8 inches. So our previous one had the diameter. We are now working with the radius. And here's our center. And again, the radius is the distance from the center to the edge of our circle. So again, the contrasting part here, the diameter on the left here is the entire distance across. And the radius is just from the center out. So make sure you get that distinction Figure it out for yourself. That gets a lot of people with these. So we have 7.8 inches for our radius. We are looking to find the circumference. Okay, so the circumference is equal to pi times the diameter of the circle. And this is one of the instances where we have not explicitly been given the diameter of the circle. So we need to do a little bit of prep work for ourselves before we do that. So again, the diameter is the distance all from one side of the circle all the way to the other side that goes through the origin. So I'm going to use gold here, but it's this entire length all the way across. Okay. Now again, as we've been told, remember back to I had the note on the other page, the diameter is twice the length of the radius. So if I know that the radius, we'll label this as r. I know the radius is 7.8 inches. I know the diameter is twice as long as the radius. I can then calculate the diameter by just doubling the radius size. So the diameter of this thing is actually going to be, and I'm plugging this into just a graphing calculator off to the side. You can do these quick multiplications like this calculator. So our diameter for this thing is 15.6 inches. So now that I know the diameter of this circle, I can plug that into my general equation and solve this thing. So my circumference is equal to pi times 15.6. Okay. And then, as again, we're gonna come back to it. We would plug 15.6 times pi into our calculator and round accordingly. So actually, if I'm looking at it here, let me bring that up right now. We'll go through these two. So the screen might go black here for a quick second while I load this. But okay. It's coming up here. Okay, here we go. So I'm going to jump us over to our graphing calculator. So if you're looking to plug in pi into your graphing calculator, we're just clearing everything out here. And this is the types of answers that you'd be getting, the types of ways that it will be displayed, and how I recommend that you go through and work with solving all of these things. So when we went through our first problem, we worked that out and we found that we got an answer to that being the circumference is equal to 12 pi. And in these problems, we're being asked round your answer to the nearest hundredth. Now, as you're going through these, do not plug in or calculate pi until you get everything boiled down to a number times pi, or number plus pi, or something to that effect. I would not apply the actual decimal value of pi until the absolute last step in the problem, because the decimal is going to be extraordinarily gross for that. So to show you guys where this thing is, this pi value, we have on the right-hand side of our calculator, it's the second option down on the right, and it's this little blue pi guy that shows up in here. So the way that we would get to that, we're going to the top left corner, we're hitting the second option, and then pi. And for the sake of seeing it, go ahead and hit enter if you have your graphing calculator out. You're going to get a big, long, gross decimal. And you'll find that it doesn't necessarily show it all the time. These will continue on and on and on and on and on. So we have some decimals shown up here. There's way more of them. And again, I highly advise you do not apply and actually use this number until the very, very, very end of the problem, because rounding early and rounding specifically with these types of problems is an absolute pain. So only apply this, only apply the actual number of pi at the very end and let your calculator do that for you. So with the specific examples that we were working with, for number 1, we had worked the circumference down to be 12 pi. So the way you're going to enter that into your calculator, you're going to enter in 12, and then you go into the top left, you're hitting that second option, and then you're selecting pi. So you should actually have 12 pi typed into your calculator. And once you've done that, hit enter. And we're getting 37.69991118. So, and again, this decimal is going to go on forever. It's big, it's long, it's gross. And you do not want to be dealing with decimals like this early on in your problem. A lot of people that have struggles with this section try and use this pi value from their first line of work. And again, the decimals are gross. They are absolutely hideous with this thing. So don't bring them into it, especially the pi value of decimals. Don't bring the pi decimals in until the very, 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 very end of the problem. Make life as easy for yourself as you possibly can, and don't make that something that you have to do. Now our problem tells us round your answer to the nearest hundredth, which means we're rounding to 2 decimal places. So the raw answer we get is 37.69911184. Rounding to the nearest hundredths means I'm rounding to 2 decimal places. So I'm rounding to here, looking to the place just to the right of it, and I'm finding, well, it's 5 or greater, so I would round up, which means my final answer is going to be 37.70 square feet. So we'll jump us back to our whiteboard. And our final answer here, we're going with in the decimal form. Oops, 37. And there we are. Now let's take a look at the second example that we just had. We had the circumference is equal to 15.6 pi. This is what we're going to plug into our calculator. I'll jump us back over there. So we're entering in 15.6 and top left second, on the right side, pi. So 15.6 pi, hit enter. We're getting 49.0088454, bunch of numbers that will come after that. And again, we are told to round the answer to the nearest hundredth. So I'm rounding to 2 decimal places. I look to the third decimal place. Is it 5 or greater? Yes. Then I'm going to round up. So my final answer for this, as a decimal rounded to the hundredths place, is going to be 49.01 square inches. So we'll jump back over there. Oops. And there we go. So again, I'm going to try and emphasize this as best I can, but do not apply or think of pi as the 3.1415 bunch of decimals. Do not apply or use that as a decimal or multiply that with anything else until the very, 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 very end of the problem. You do not want to work with those decimals early on with this. They're absolutely gross. They're terrible. You don't want to work with that. Okay. So we're going to work with our third example from that section, which is going to kind of let's do something a little bit different with these. Sorry, our screen's being a bit weird here. Okay, so our third example from that section, we were told find the diameter of the circle with a circumference of 147.58 meters. actually, we're just working with circumference, so we don't need the square in here. So that's a mistake on my part. Okay, so we have been told, again, we're finding the diameter of a circle with a circumference of 147.58 meters. So again, we're seeing circumference, we're working with a circle. Let's get that general equation in there. And then we'll draw a silly little picture for ourselves to get a visual of this thing. We are told to find the diameter of the circle. So we do not actually know what the diameter is. But we have been given the circumference, so we can solve for that. We are told the circumference is equal to 147.58 meters. So in our general equation that we have been given, we can plug in 147.58 for the circumference, and we're going to solve for the diameter. So we have our general equation written out there. So we substituted that value in for the circumference because that's what's been given to us. And now we need to solve for the diameter. And we're solving this thing just as if we were solving any other problem before this. A lot of people think, well, okay, pi is a very specific or very special number, so it probably has some special properties attached to it in terms of what we can and can't do. And not entirely. It's just a number. So let's say that instead of that symbol for pi being there, what if it was the number 3? How would I get the diameter, that d, all by itself? Well, if that was just the number 3, I would divide both sides of the equation by 3 to get the diameter all by itself. And we're going to do pretty much the exact same thing, except instead of dividing by 3, we're going to be dividing by pi. Because pi is just a number, doesn't have anything particularly special about it in terms of how we go about doing these properties, these calculations. So we would find that the diameter is going to be equal to 147.58 divided by pi. And again, when you get to this point, apply your calculator. So we'll jump over to our graphing calculator example, and we'll take a look at that. So we're entering that in. We have 147.58. And then we are dividing by pi. So again, that's top left. We need to go to the second option. And then the right-hand side, far right-hand side column, second one down, pi. 147.58 divided by pi. And then hit enter. We get 46.976173. We are told to round the answer to the nearest hundredth. This is 2 decimal places. Part to the right is 5 or greater, so I'm going to round this thing up. So my final answer for this is going to be 46.98 meters. Oops. What is going on with my screen today? It's lagging a bit on me. There it goes. And now we'll take a look at our last example with this. We are told with the fourth example, find the radius of the circle with a circumference of 20.72 yards. Okay, so once again, we're working with the circumference in here. We're working with the radius also. So our general equation for the circumference is equal to pi times diameter. And then because we're going to be working with the radius and the diameter, our equation that we have here does not explicitly have the radius in it, we're probably going to want to write down the relationship between the diameter and the radius as well. Namely that the diameter is equal to double the radius. Because we're probably going to use that here in a little bit. And spoiler alert, we will be. So we have, you want to draw that circle. We are trying to find the radius. It's our unknown. So we're going through this. So we have been given a circumference of 20.72 yards. Just writing down the information that we know. And plugging in what we are looking for from there. So I'm plugging that 20.72 in for the circumference. And I can go through this thing and now say, okay, well, I want to find my end goal is the radius. I do not explicitly have, what's been given to me, I do not have an explicit equation that contains the radius in it based on what I am starting with. And I mean that from the standpoint of our original equation here does not include the radius, it includes the diameter. So we're going to solve for the diameter, and then we're going to cut that diameter in half and solve for the radius. So we're doing this in parts, breaking this down piece by piece. So just like we did previously, we have, like our previous example, we're solving for the diameter. So I'm dividing both sides by pi. And for the sake of time and keeping up these, I'm going to do this off screen, but we're just going to do just like we did previously, 20.72 divided by pi. We're being asked to round this thing to the nearest hundredths. Okay, so my diameter, when I do this and plug that in, after rounding, I'm going to get the diameter of 6.60 yards. Now again, I found the diameter. I'm being asked to find the radius of this circle. That's my end goal. So I'm almost there. I have an equation that tells me about the relationship between the diameter and the radius. And I can plug in the diameter in for that equation because we just found it. So now I'm just trying to get the radius all by itself, dividing both sides by 2. And I'm getting that the radius is 3.30 yards. And there we go. So be ready for having to go back and forth between our diameter and our radius equation that we have here. Or diameter or radius, because depending on what information that we have been given. So again, write out your original equation that you're working with. I think a silly little picture is really nice to have as a visual. You don't need to do that, but I tend to find that people who draw these pictures in for themselves, they tend to score a little bit higher on the homework. They tend to score a little bit higher on the tests. It's not guaranteed, but it does help, I think. So this is everything for the 10.9 material. I'm going to jump us back to our lecture notes, and we'll go into 10.10, working with the area of a circle. Let's move this over here so our space is ready to go. So 10.10 is having us working with the area of a circle. And our equation for the area of a circle is the area is equal to pi times the radius squared. So r pi r squared, where r is the radius. So very similar to what we just did with the circumference. We're going to be plugging in the radius or the area, and we're solving for whichever is the unknown. The relationship that we have between the diameter and the radius is the exact same thing, which means we will need to be ready to go back and forth between I've been given the diameter, I need to find the radius. I've been given the radius, I might need to find the diameter. So going back and forth between those two relationships is also going to be coming up with this as well. But for the most part, otherwise, a lot of this is plugging in what we've been given and solving for whatever is unknown. So we're going to look at our examples. We're going to look at some of these because then I do want to get to a bigger example down here because this is worth going through. So we'll go through a couple of these, but again, the process is going to be very similar with these four to what we did with our previous four, except we're just working with a different equation is all. So we'll jump over to our whiteboard, blackboard I should say, and we'll go through some of these. So our first example that we had we were asked, determine the area if the radius is equal to 12 meters. So we've got our picture here. Our radius is 12 meters. We are working with a circle. We are working with the area of a circle. So get that general equation written down for yourselves. So area is equal to pi r squared. We have been given a radius of 12, so I can plug that in. And we're plugging in what we know. And now we're simplifying and evaluating from here. So again, if you're looking at that pi and thinking, okay, well, this is going to change everything that I do, how I solve it, pi is just a number. It's all you can think of. It's just a really fancy, gross-looking number. That's all it is. So as we are going through and simplifying this thing, we are going to be following PEMDAS in our order of operations. So parentheses first, can't do anything to the 12. Exponents, I have everything inside the parentheses being raised to the second power, which is the same as saying 12 times 12. I'm just going to write that out explicitly once here, just so we are seeing that. It's a refresher. Multiplication, 12 times 12, it's going to give me 144 times pi. We now have 144 pi, and now we plug that into our calculator to find our answer. So just like we did with our previous examples above, you're going 144 pi into the calculator. We are told to round to the nearest hundredth again, and after plugging that in, I'm getting 452.39 square meters. And I'm done. Taking a look at our second example. We're told determine the area if the diameter is equal to 12 yards. Just going to draw our silly little picture. That's not very good. It's a little too silly for my liking. There we go. So we're told the diameter is our center. Our diameter is 12 yards. We are looking for the area. And because we need the radius for this thing, we have not been given it to us explicitly. It's not been given to us explicitly. We're going to need to use that equation that tells us the relationship between the diameter and the radius. So we need to rewrite this diameter and figure out what our radius is. And then from there, we can use our equation to find the area. So if our radius, or our diameter is 12, I'm plugging that in. Divide both sides by 2. I know the radius is 6. So I can now plug that in for the area. We'll plug it in for the radius in the area equation. And I can solve this thing from here. 36 times pi. Again, plug that into your calculator. I'm getting 113. Ooh, I don't know what that is. I'm getting that the area is going to be 113.10 square yards. Take a look at number 3, and then I'm going to jump us to the geometric shape one because I do want to give that some time. So number 3 is telling us determine the radius if the area is equal to 226.87. So we've been given the area, we're trying to find the radius. We're going to be using our general equation for that. And now from here, we're plugging in what we know and solving for what's left over. So I know I'm going to have 226.87 for the area equals pi r squared. Now I want to get that r all by itself. So I'm dividing both sides by pi, because that's the whole number out front. Or that's the number out front, I should say. And I'd recommend when you have instances like this, again, I'm giving you guys, here's the step-by-step on it. Do not plug the left side of that equation into your calculator yet. We're one step away from you being able to do that. Right now on the right-hand side, we have r squared. We do not want r squared, we want just r. So we need to undo that exponent. The way we undo that exponent, especially with the 2 there, we're going to take the square root of both sides. So take the square root of the right side, take the square root of the left side, and this whole square root that we have written out on the left side here, that is what we're going to plug into our calculator, and I'll show you guys how to do that. But this is the stage right here. This is the point where you would be plugging things into your calculator. And the calculator can handle this. It can do this no problem. So we'll jump us over to the graphing calculator and show you guys how to enter that in. Oops, wrong one. That's not the calculator. So to enter this thing in, we're going to go into, I'm going to first put in, we want the square root of something. So we're going second, left-hand side, the square root option. Now yours might show up a little bit differently in that yours might have parentheses showing up at the very beginning. That's fine. That's just the different version of calculator you have. We were working with 226.87 divided by pi. So that's what we're plugging into our calculator. 226.87 divided by, we're doing second pi. If your calculator is showing up similar to this, where you are not explicitly seeing any parentheses showing up right now, then you would click right on the arrow key and then hit enter. If yours is showing up where you do have parentheses showing up on this left-hand side over here, then you need to end the parentheses by clicking this little right parenthesis here. And then you can hit enter and it will calculate that value for you. So we get 8.4979, a bunch of stuff there. We're told to round to 2 decimal places, so we're getting 8.50 for our final answer. We're good there. Now, I'm looking at our time. We don't have a lot to go through with this, but I'm going to give you guys the quick breakdown of how you'd want to go through that geometry problem, or geometric shape problem. And this is, you're going to see some of these like that, like this might be showing up on the homework. I do like putting problems like this on the test itself. But again, I think the big part that gets a lot of people with this, and it's got a lot of people on the previous test, was trying to do everything in 1 or 2 steps. And it's a lot harder to do that. So my recommendation when you have something like this, we're told to find the area of this given shape. You're going to want to solve this in pieces. Primarily, I'm looking at it says we have, in blue here, we've got a square. In red, we have a semicircle or half of a circle showing up. So my recommendation, if we are trying to find the area of the entire shape, find the area of each of those at a time. So solve for the area of the rectangle. Again, our equation for that, area is equal to length times width. When we are solving for the area of that semicircle, it's going to be half of a full circle that we have there. So find the area of a circle using our equation that we have. And then say, well, because we're taking half of it, we're going to divide by 2. Once we have the area of the rectangle, once we have the area of the semicircle, we can bring these together. We can have the area of the rectangle plus the area of the semicircle, which equals our total area. So again, the raw numbers with this, I'm looking at our time here. I don't want to keep you guys longer than our regular allotted time. But with a lot of these geometric shape problems, you want to break them down into smaller parts that you know you can solve on your own. You can solve, you guys know how to solve for this area of a rectangle. I know you guys know how to do that. The area of a semicircle, okay, you can do that with a little bit of modifications to it, that's fine. And then once you have each of these parts, you bring them all together for the final answer there. But again, a lot of people make the mistake of, I see a shape that looks a bit weird, but I'm assuming there has to be an equation that solves for any and every single shape that's ever been created. And unfortunately, there isn't. So that's why we need to break these things down into their parts and solve for their parts and then bring it all together at the very end. It should also be stated that as we're going through this last note, and then I'll end our recording here. If you're wondering, okay, well, I have a semicircle, great. How am I going to determine what the radius is to find the area? Well, I have the diameter showing up right here. If I know the diameter, I can find the radius. And if I can find the radius, then I can find the area. Go through and solve it from there. So I'm going to end the recording here. We ran a little bit later than I was originally anticipating today, but this is the last of the new material. So woohoo, we're done with new stuff. All right, I'll end the recording here, and then I'll stick around here for a little bit. If you guys do have any questions, we'll go through stuff accordingly.